All right. Hey guys, welcome back to another video. So today I'm going to be talking about U sub, um, but we're going to be doing definite integrals this time. So there's with a definite integral, there's kind of just like one extra step, right? And so there's two ways that you can do a U sub with a definite integral. The first way is because we have limits of integration, that kind of changes things up because, for example, when I do a U sub, I can't keep those limits of integration. Right? So that is like these boys right here, right? I can't keep those limits of integration for my du, right? Because these limits of integrations are for x variables, right? There's two ways that we can go about this. The first way is that's fine. We can just substitute u back in, and that'll be fine. Then we'll have an x back in the equation, and so now you can use those limits of integration. But sometimes u sub can get really, really long, and sometimes you have to do multiple u subs. So maybe kind of just like replacing the u back in is not the best way to do it, just in case you do have some of those like very extensive u subs. So instead, what we're going to do is we're going to change those limits of integration, right? So the way that this works is we're going to proceed with our u sub as normally. So I'm going to let u equal cosine of x because that's kind of the piece that's causing me the most difficulty right now. So if I let u is equal to cosine of x, that means du is going to be equal to negative sine of x dx, right? So now this is just a very quick substitution. But before I do that, here's where I'm going to change my limits of integration, right? So because my limits of integration are in terms of x, if I want to change from x to u, I have this very handy formula right here that can tell me what u is for variables of x. So since 0 and pi are variables for x, all I have to do is plug them into this and I can get variables for u. Right? So what that looks like is, okay, u for, we'll do 0 first. This is equal to cosine of 0, which is equal to 1. And then u of pi, this is going to be equal to cosine pi, which is negative 1, right? So now my new integral with all of my u stuff substituted inside is going to be from 1 to negative 1, right? So we're going to keep that 0 and the pi u's in the same place, right? We can't change it just yet. So now we're going to have cosine of u du. Negative. My bad. This is going to be a negative sine of u du, right? Okay. So now that we have this is like a very standard integral that we know how to solve, right? So we're going to flip those limits of integration, right? So this is going to be positive 1 to negative 1, negative sine of u du, right? So this is going to be cosine of u evaluated from 1 to negative 1, right? And so here, this is the nice part about kind of changing your limits of integration. We don't have to substitute back in. I can just evaluate cosine of u at 1 and negative 1, right? I can just evaluate it, and that'll be my final answer. I don't have to substitute anything back in. So when I do this, I'm going to get cosine of 1 minus cosine of negative 1, right? But since cosine is an even function, cosine of negative 1 is equal to cosine of 1. So this is going to be cosine of 1 minus cosine of 1. So we get 0. Right? So this is what I was talking about with definite integrals. And so this is how you would kind of go about doing the u sub. You can substitute everything back in at the end if you don't change your limits of integration. That's totally fine too. I find this method just a little bit more convenient, just in case you guys do have to do multiple u subs. So yeah, I hope this was helpful to you guys. Thanks for watching. Hopefully you learned something.